G'day again. This is just a video on a few different special cases for sketching. So what we're going to do for sketching, I'll just write up here for sketching graphs. Okay, and I'll just write them down as we go. Firstly, when we've got, I should just go straight into an example. I'll just go straight into an example. When we've got y equals 2, how would you sketch the graph for that? And so y is just equal to number. Remember how we had, usually we've got y equals mx plus c, we've got some x in there, that sort of thing. In this case we've just got y is equal to a number. So this is a bit different. Let's just try and sketch this and have a think about what it looks like. Y is equal to 2. Right, let's plot the point. What happens when x is equal to 1? When x is equal to 1, y is equal to 2. Okay, this is what this is telling us. How about when x is equal to 5? When x is equal to 5, y is equal to 2. So it actually doesn't matter what x is equal to, y is always equal to 2. What about when x is equal to negative 10? When x is equal to negative 10, y is still equal to negative 2. So I don't care where that is. Oh, it's definitely not there though. That point there though. And so what this means is it doesn't matter, for every x value, y is always equal to 2. And so this graph is actually the straight line like this. Oops, goes down. It's a dead straight line. This is the line y equals 2. And so when you get an equation where y is equal to a, some number a, it just crosses at a and keeps going. It's just a dead flat line. So y equals a gives you a horizontal line. And every y value is equal to a. In this case it was always equal to 2. Y was always equal to 2. And so that's what it looks like. And if you want to think about this in a different way, if you've got y equals mx plus c, if you want to write this equation as y equals mx plus c, that's really y equals 0x plus c, isn't it? Y equals 0x plus c, because that bit would just disappear. And that's telling you that it's got a gradient of 0. And you can see here this line has a gradient of 0. It doesn't go up or down, it goes just flat. It's got a gradient of 0. And it crosses the y-intercept at c. In other words, this one crossed it at 2. It crosses at 2 right there. And so that's what you do when you're asked to sketch it. Well, so what would the graph of y, if you had to go y equals negative 5 look like? What does that one look like? Well, that will cross at negative 5. 1, 2, 3, 4. It'll cross there, and it'll be a flat line. I wish I could draw straight lines, but that would be the equation y equals negative 5, where it crosses at negative 5. Okay, so that's our first special case. Let's have a look at another one. Let's do the case where you've got x equals something, and hopefully you'll be able to figure out what this might look like before I sort of get to it. Okay, so special case number 2 is something like this: x equals negative 4. Let's have a think about it. What does this look like? So let's just plot a few points again. Let's plot a point when y is equal to 1. When y is equal to 1 here, what's x equal to? X equals negative 4. 1, 2, 3, 4. This one here. Okay. What about when y is equal to 10? Up here somewhere. X is equal to negative 4. What about when y is equal to negative 9 or something like that? X equals negative 4. So you can see it doesn't matter what the y value is, x is always equal to negative 4. And so what you get is this line, vertical and straight. Oh, no, vertical is harder for me than horizontal, just because of the way the tablet is. That's a bit better. So that goes through the point negative 4. So this is the line x equals negative 4, and it goes up and down like that sort of thing. So there you go. It's exactly like the other case. So if you had to sketch the line x equals 1, what would that look like? That'll be a vertical line through the point 1. Like that. And there we go. So that's the special case number 2. So if you get x equals, no, let's just clean that up a bit. It's a bit messy, sorry. You get x is equal to b. You get a vertical line through B. Okay, so if it's x equals 1, it'll cross at 1, and it's just a vertical line. Okay, so that's your second special case. Nice and simple. If you see those, don't get confused by them. They're actually really, really easy, but they can mystify a few people. The last one is if you get something of the form y equals mx. Okay, and I'll just, I think I'll just launch into an example because I think it's just important. I did sort of say it was an example, didn't I? Y equals 3x. Okay, how would you sketch that guy? Well, if you compare it to y equals mx plus c, y equals mx plus c, it might give you a hint as to how to draw this. Because what you've got here is y equals 3x plus 0. So what does that tell you? It tells you that the y-intercept is 0 and that the gradient is equal to 3. Okay, so m is equal to 3 and your y-intercept is equal to 0. And so what you do for these guys is you just sketch it using your gradient intercept method. Y-intercept is 0, you start at 0. The gradient is 3, which we can also write as 3 over 1. So your rise is 3, your run is 1. So what that means is you go up by 3 and across by 1 to your new point, and you draw a line between them. And that's what the equation y equals 3x looks like. And this makes sense because y equals 3x is just y equals 3x plus 0. It's got a y-intercept of 0. In other words, it goes through the origin. Through the origin. And everything that looks like y equals mx will always go through the origin because it's always got a plus 0 there. It always has a plus c. It always goes through the origin. So that's how to sketch those. And that's it. Just a couple of special cases to know what you do when you come across those. Cool.